One. Okay, let's get started on this one. Hi, everyone. I'm Raghu Vatte. I'm the field CTO and VP strategy for ZEDEDA. And today we are here to talk about how we can tackle the connectivity issues and problems in the edge environments. Today I have with me Jeff and Daniel, who are going to be helping us discuss and also talk about how ZEDEDA can help dealing with the connectivity issues. And we will go over a product that we have just released, Edge Sync. First, Jeff. Jeff is a 27-year-old veteran at SLB, formerly Schlumberger, for people who know Schlumberger a lot more than SLB. And Jeff is a cybersecurity architect at ISES in the tech dev group. Jeff has worked with various different technologies that are done in oil and services industry. And I'm very pleased to have Jeff on the panel today. Along with Jeff, we have Daniel, who is going to be presenting Edge Sync today later in this webinar. He is a senior principal PM at ZEDEDA, and he comes with a lot of experience in terms of dealing with Edge, both at ZEDEDA and his prior lives in Nokia and other places. Let's first start with Jeff. Jeff, first of all, thanks for joining us. It's great to have you on this panel. Can you, first of all, introduce yourself? I'm sure like I didn't do justice by just talking about you in a minute. Can you first of all introduce yourself for our panelists?
Yeah, hi, Raghu, thanks. Yeah, I'm Jeff with SLB, as you said, 27 years over that now. I am currently working as an IACS cybersecurity architect in our tech dev organization. Basically, the tech dev organization deals with the field operations. So just about everything that goes on in the field operations in our various segments is kind of something that I have to dabble in. Part of our cybersecurity role now is to, of course, try to push more security down into the products themselves. That includes from the networking to the tools to the software, firmware, stuff like that, that ride or compose of that. I'm not sure if anybody's aware, but SLB is basically a technology company. We're multinational, over 100,000 employees at the moment. And what we do is we just provide technologies into the various areas that we're really good at, which is getting data and delivering data to where it needs to go. So basically, it's pulling data from tools, services that exist out at the remote field operations, bringing it up into a centralized area a lot of times, and then delivering it to customers who acquire our services.
Okay. Thanks. And I'm pretty sure like SLB and Schlumberger are like household names in some parts of the world, but they might not be for all of our guests that are on this webinar. So can you just describe briefly what SLB does in terms of the overall oil and gas services, and also like what your team does specifically in terms of when you say getting the data, what is that data, and what are the tools that you would be using, just at a very high level, please?
Yeah, so oil and services energy, or the energy sector, really it's energy now because we're now getting into geothermal as well. Mm-hmm. What we do is we assist the majors or whoever wants to contract with us to acquire data either through a drilling methodology, meaning if we have to drill holes into the earth, we do that. The tools, that whole process really is built around data. And the fact that evaluation, the formation at the top level is gathered. We go through as when we're actually drilling, we're gathering data as we're doing the drilling. We also gather data after the well's drilled. There's also other things like we provide services for ensuring data integrity of the well. So anything built about dealing with the energy is something that Schlumberger is involved with. And that includes even, like I said, geothermal now. So we're getting into supporting geothermal efforts, assisting those that wish to take and acquire that, or at least implement that, usually at a fairly large scale, because that's what we're good at. We're really good at acquiring that data. But we do it all the way across. I mean, I don't think there's a area that we don't dabble in as far as any data dealing with energy. Mostly downstream, but we do some upstream as well. So
it's funny. Like, I mean, I have been dealing with oil and gas services companies and also oil producers. And when I first started looking at this field, you wouldn't think of oil and gas or energy and think of data. Data is not the first thing that comes to your mind. And it is so important in terms of the kind of drilling and the kind of characterization. All of these things happen. It is like over a period of time, like I've realized that like there is so much more technology in companies like yours than like that is widely perceived to be. It's almost like, oh, there is an oil and gas services company, they go out and drill. But it is not that. There is so much more technology and there is so much more engineering and ingenuity. I'm always amazed by the kind of techniques that are used and everything else. So in this gathering of data and everything else, what is it that makes cybersecurity very important, or what is it that makes the data security very important? How is this data important for your company and also for your customers? Can you just talk a little bit about it, and why is it securing this is so important for all the parties that are involved?
Well, so first off, the data tells them everything they need to know about the formation that they're drilling into. So it gives them a feel for what they'll produce, how good it will be as far as, meaning, did we drill the right place? If we overshoot something or undershoot something, it may perform less, but, so you have to use this data to analyze where exactly do I need to go. And that includes stuff from the top side where we actually use methodologies to take and gather what the formation looks like from the ground. So we'll actually sit above and do surveys, formation surveys using equipment at the top, using, shows and sound down there, gathering that data, pulling it up and taking a look at what that looks like. But we also do it while we're, actually drilling the hole itself. But there's also things that occur afterwards, is how well is the well producing? So, not just the initial formation, but also the afterwards. Well, all that information is valuable. And if you start losing it, or if you get it compromised, then you have the possibility that what you think you know isn't what really is. So therefore, you need to secure down that whole chain. You need to make sure that what you're acquiring is valid and accurate. And then you also need to make sure that it stays accurate, not only during the initial retrieval, but also as you're transmitting it to your customer. And nowadays, the customers want to see this data in real time. It used to be in the past, we would gather the data, we would produce a log, and we'd deliver the log, sometimes on paper and stuff like that, to the customer after the job was done. Well, you can't make decisions after the job is done. You basically just know what you did.
Yeah.
So now they want to know what is going on while that's occurring, not just, while we're drilling it, like I said, but also what is it doing now? Like after you get done, how much is it producing? What is it producing? What are the volumes I'm getting out of it? Stuff like that. So all that is very important to the customer because that helps their profitability. The other thing that we do with the data is, if we're knowing what's going on, we can actually potentially improve the process to reduce the cost to actually do that particular penetration. So all that is important to these companies that are doing or gathering the wells and producing the energy and stuff like that. So it's just really important that you keep it good and that you make sure that it's accurate. And then of course you want to make sure that you don't become a vector for someone to take and come in and use you to get to someone else. So that's the other thing that, where cybersecurity is ensuring that we don't get infected in the first place, or we don't get compromised. ensuring that we don't compromise someone else, and then also ensuring that what we're delivering is actually accurate.
Perfect. And talking about today's topic in terms of connectivity, how connectivity is needed to actually transmit this data or give information to the job sites that actually are creating or generating this data. But even before we get there, so if you go back in time, even 10 years or 15 years ago, when this data is generated, can you comment a little bit on the volumes of the data that were generated and how they would be transported, or how that data is transported and to a place where it would be consumed? Can you comment on that in terms of what it was before historically, so that our audience can appreciate how things have changed and what it is today?
Yeah, so the data volume, I don't know if it's changing too much, but let's say we're doing a seismic job, which seismic job is where we go out there and we measure the formation from the surface or slightly below the surface. That's usually, we're talking gigs of data per minute potentially. Those we pretty much have to deliver on hard drives. But other things like the information within the well and stuff like that, a lot of that can be acquired and transmitted in real time, because the data points are such that they're not at a frequency where it will overflow some of our technology that we have to use. Now, you have to realize where we do this stuff is usually in the middle of nowhere. I don't necessarily have a nice 4G, 5G cellular connectivity. It may start dropping down closer to 3G, or I may have to resort to VSAT type connectivity. So a lot of times the connectivity isn't the best. So we have to make do with what we can afford. And there's just certain electromechanical restrictions about what you can do. I mean, I can't take a 7-meter dish out with me to some of the field locations, because that takes a lot of effort to set one of those up. So we have to have some restrictions on what we can achieve, even in bandwidth value or bandwidth volume. So we have to do that. So we also go through the process of identifying what is important now and what needs to be delivered after the job is done by coming into a field office or some physical location where we can deliver it at a faster speed. Now, it could be that maybe what it means is we just driving somewhere and we'll finally get somewhere where the connectivity increases such that we can deliver the data. But it may be that we have to wait till we get somewhere else and then we turn it up and we deliver the data. So we do various methodologies as far as how that data is delivered to the customer when they need it.
Oh, great. And thanks for that. And when we talk about data and actually acquiring this data, there are two, I mean, at least in my mind, there are two different personas. One is the persona who is actually consuming that data and creating or creating insights or creating decisions out of it, or creating reports for the future. And the second one is the field operators who are on the site, and their job is to make sure that this data is generated, its integrity is preserved, and all the things about securing the data, and while it is generating and also while transporting, all of these things also are part of their life. So what would be a typical day in the life of that field operator be, especially when you're talking about very low connectivity situations, or sometimes I'm guessing the connectivity itself is not there, right? There might be
there's cases where we don't have any connectivity.
So what would be a typical day in the life would be for the operators?
That's going to vary a little bit in the fact that sometimes our jobs are really short. Could be 2 to 3 hours, and then other times it could be days. So it just really depends. In a short thing, they would roll up on the location that they need to work at. They would set up their equipment. They would perform their job, retrieve the data they need to retrieve, transmit what they need to transmit, and then store the rest, and then close up and head back somewhere else, or maybe into the next job. Sometimes they have a couple jobs lined up. Other ones would be more of a long-term deployment where they're maybe there for multiple days, weeks even. They would show up in the location. They would monitor the current process that's going on, ensure that it is recording data correctly and that everything's working that they are supposed to be providing, because they'll have a list of what they need to do. So they'll validate that that is occurring. Any data that needs to be delivered during that time period, they'll be delivering that data, whether it be the tools gathering the data and sending it streaming off to a town type environment, or whether it would be collecting it and doing a kind of a bulk upload occasionally. So they would do that. And then usually what happens if it's a multi-day event, there's probably shifts going on. So we have a daytime shift and a nighttime shift. So they switch on and off depending on what was going on. And we would have that occurring throughout the particular job that was, at that location.
And I mean, there is one thing about like the data that is being generated in this job site and then transported and everything. But I'm guessing there is also communication between the job site and whatever is the central location, or some other thing which would like control the applications that are generating this data. Or that would actually control the equipment, or there needs to be communication in terms of the job site and whoever is responsible for orchestrating all the jobs or things like that. How much of that data communication is important? Does that come into picture every single day, or is it only important when something goes wrong? So how does your field operations handle it when the connectivity is not there or something goes wrong? What do they do?
Well, so if there's no connectivity, that's where it becomes tricky, in the fact that they end up having to try to pull up cell phones and check in, find out if there's anything that needs to be changed for that particular operations that they're responsible for. Ideally, that is not the case. We prefer to try to do most stuff online, just because, like you said, they're reporting what is going on, and they're also getting updates as far as, okay, things have changed. Maybe something has been requested that wasn't in the initial plan that they had, so they might have to modify the plan a little bit. So those things will be occurring, routinely throughout in a field operation job.
Mm-hmm.
In offline cases, though, what we've done is we've built the tools and everything to store the data, basically a store and forward. So we try to make sure that we collect the data that we need, perform the task, and then if the connectivity is restored, then it will start forwarding the data off. And then, of course, if new requests needed to come in, they would be retrieved and brought in at that point in time.
When you are talking about like collecting this data and making sure that like you can first of all store and forward, or like even when you are online, like you are able to like actually send the data. You initially talked about if we know the data after the job is done, we just know what happened. We cannot actually take decisions on it, right? But now with all the new technology and everything and all the new tooling, are you taking decisions based out of the real-time data? And if you are taking decisions, who is taking those decisions, and how does that information get back to the operator, or is it fully automated so that the operator is not in the picture? Can you comment on that? I mean, as much as you can.
So it depends on the particular tool. So certain tools, have enough intelligence built into them, and we're adding more intelligence. I mean, as you know, AI is a big buzzword nowadays, and we're actually looking at, what can we bring to the operations to run AI locally, whereby, more intelligent decisions can be made there. But, if the tool has enough smarts, it can make some decisions. But, of course, there's always the unknown that if the plan needs to change dramatically, yes, we wouldn't have that information except through some sort of call methodology. So if I'm offline, probably the only way I'm ever going to get the notification that, oh, yeah, we meant to do this at this stage, you need to change to that. That would have to be some sort of phone call to be told, hey, I need you to make a change in the plan to do this instead of that.
Mm-hmm.
If there's a lot of dynamic changes going on, though, let's say it's something that we know that there is impending changes, we might even slow the job down a little bit to ensure that we can keep that connectivity going.
Okay. And one question on just slowing the job, and what does it mean? And this was definitely a surprise for me when I first started learning about this field. Is like, can you comment on, okay, you talked about like there is a 2-hour job, right? Like
Yeah.
what happens if that 2-hour job becomes a full day job because of one reason or another, or you're supposed to be at a place for like a few weeks, and then you have to stay for like another one more week because of whatever connectivity issues or other things. For our audience, can you talk in terms of what does it mean for the job? What does it mean in dollar cents? Because it just paints a picture that like
Yeah.
people can understand.
Usually there's some sort of loss of revenue, but we can also have a loss of reputation. We're definitely doing some sort of NPT time, which is non-productive time. Could be client-based, could be definitely our side. So we try not to do that. Meaning, as much as possible, we want to make sure that there's zero NPT, because we've basically agreed with the customer to say, hey, this job will take this amount of time.
Mhm.
And we've kind of agreed that we will deliver the data in X period of time, be it either real time or even after the job. So all that has kind of been set up ahead of time in the contract to ensure that, this is what we're going to operate. So the SLAs have been laid out. If we're deviation from that, yeah, there's going to be impacts. So it can be fairly reasonable impacts if it's onshore, to very expensive impacts if it's something that's offshore.
Okay. And you don't have to talk about numbers if you don't want to, but just for our audience, if a job doesn't go well offshore, are we talking about hundreds of thousands or like millions of dollars of revenue impact?
Let me give you a figure for a single offshore platform. I heard that offshore platform was running at 190K per hour. So every
190K per hour.
190,000 per hour. So if something stops operations, and it doesn't have to be us, it could be something else. Maybe a piece of hardware breaks on the rig, or maybe there's an emergency that they have to kick in for some other reason. That client is incurring 190,000K of lost revenue, or at least expenses that they weren't planning for.
Wow.
So yeah, offshore is really, it's a whole new ballpark as far as figures. Onshore is probably a little bit less, but you still have to realize is that if they're doing an active drilling, they're paying for that rig time. So the
Yes.
rig, when it's there, is costing them so much per hour, and they expect to do X amount of effort with that particular rig, because they're trying to keep their cost down. It's all cost driven nowadays. There's nothing that is not. I'm just going to go out there and see what I can happen, and if I get
Yeah.
lucky, great. That doesn't happen nowadays. There's very few specs. I think a few oil companies will do some speculation wells, but that's because they're already pretty sure they're going to find something.
Okay.
So speculation is probably not happening as much as people think anymore. So you got a little bit of that going on. And the actual equipment a lot of times is not owned by the customer. They rent it all.
Mm-hmm.
They don't want to keep that asset on their books, so they're renting everything. And as such, they know what it's going to cost per hour for an onshore or offshore rig, or even per location. And we just try to make sure that we, as a service company, do not impact that cost structure if we can.
Oh, definitely. I mean, when you are talking about like millions of dollars per day, I mean, 200K per hour. Yeah, I can do the simple math. But like it's $3-4 million per day, or like even inside, like if we are doing like even a quarter of that, it's still it's a large amount
Yeah.
to take the risk on. And obviously there is a repetition factor because these are I mean, it's not like SLB has become what it is by losing their reputation. You are known for your quality, you're known for your reliability and the SLAs that you provide. And I'm pretty sure those are very, very important for everyone in the company, right? Otherwise, you
Yep.
can't build a 100+ year old company just on without having those kind of disciplines in the company.
No, we make sure our SLAs are met.
Mhm.
I want to say most of the time. It's very seldom that we would not meet an SLA.
No?
And
And
we just plan everything out. We know what's okay. If I'm going here, I need to take and bring this amount to ensure that I get the job done.
Again, coming back to today's topic, there are a lot of moving parts uh, in these operations. And if we talk about connectivity, and I mean, apart from the obvious ideal solution of, okay, I need like full connectivity all the time. What would you, but that is not reality, right? That's not going to happen. Like you are going to drill in places that doesn't have other infrastructure around it, and especially when you're exploring and all of those things. So what would an ideal solution look like for you when it comes to connectivity side of the picture? And how would it actually change the life of your field techs, both in terms of their quality of work, but also in terms of optimization and everything else that is associated with it? What do you think would be an ideal solution?
An ideal solution is something that can ideally work with just about any sort of connectivity methodology.
Mhm.
There's some that I don't know if I'd ever want to try again, like we've played with BGON a long time ago. The latency was just so bad on that it was painful.
Mhm.
But as long as we get decent latency, and when I say decent, I mean under 2 seconds latency with adequate bandwidth, and the bandwidth could be in the 500K range. I think we can at least do the minimal items that we need to do. Now, more is better, of course. Faster is better. So any a system that can use any type of technology to transmit data and then deal internally to say, okay, this is important. Let's get this off immediately as soon as I got some spare cycles to send it. And this other stuff I store and forward.
Mhm.
That's
Uh,
ideal.
Thanks a lot for that information. And like, I want to like pivot a little bit into the product that I talked at the starting of this webinar, Edge Sync. This is a product that ZEDEDA has just released. And we went about it I'm talking to a lot of the people who are in the industry. We looked at this whole holistically and decided that like there are two pieces to this puzzle. One is like, how do you get the data from wherever it is generated and sent to the place where it could be consumed, whether it is locally or into a data lake somewhere. And the second piece was like, how do you manage all the assets that are out in the field, even if you do not have any connectivity to manage it? And as you know, like ZEDEDA is an edge management and orchestration company. We help our customers manage all the assets out in the field in various different verticals. Need not be oil and gas or energy vertical. The same is true for manufacturing. The same is true for automotive. The same is true for healthcare sometimes, or DoD, where the connectivity to the asset is not always guaranteed. Sometimes it is fully air gapped, and in other times it can be very unpredictable. And to address the need to manage these asset classes that are out in these connectivity profiles, where the connectivity is not guaranteed or whether the connectivity is not at all present, we came up with this Edge Sync uh, feature that enables our customers to manage these assets even when they are not connected. And to talk more about it, I have invited Daniel, who is our senior principal PM. And Daniel, do you want to take it from here and talk more about the Edge Sync product?
Absolutely, absolutely. Thank you so much, Raghu and Jeff, for that interesting overview of operating in disconnected or semi-disconnected environments. So while I share my screen, so as you already indicated, Raghu, we provide a edge management orchestration solution. ZEDEDA's edge management solution is a SaaS-based solution. So that implies some level of connectivity of edge devices to the cloud for the management plane to be able to control devices. And as we've just discussed, that connectivity might be intermittent, or we might have cases where that connectivity is is not available at all because somebody operates in an air-gapped environment. And this is where Edge Sync comes into the picture. So Edge Sync is a solution that we recently launched, and in the next 10 minutes or so, I wanted to just give you a quick overview of what Edge Sync is about, what kind of scenarios it addresses, and how it helps to deal with these disconnected scenarios. So first of all, what is Edge Sync? Edge Sync is a secure and seamless local monitoring and access solution. It gives a local operator, somebody local to the edge devices, a means of interacting with those edge devices, even when those devices are disconnected from ZEDEDA's cloud management solution. It still, even in that scenario, allows fleet level management of those devices, so fleet level management of air-gapped devices. It supports intermittent connectivity scenarios, so you may be disconnected for a short period of time or a long period of time. And it also allows transitioning between these different states. So maybe you start off with a set of devices in a use case that for whatever reason need to be air-gapped. And over time, maybe there's a reason why you can allow network connectivity more freely, and those devices no longer have to be air-gapped. And the solution allows you to actually seamlessly transition between these different scenarios. Given that it gives an operator locally access to the device to interact with it, it helps to also prevent service downtime at the edge when you don't have network connectivity. So let's say an application failed for whatever reason, Edge Sync gives the local operator a means to restart an application, for example. And finally, it is an API infrastructure. We'll talk a little bit more about that in a little bit, but it means that it allows you as a customer operating this infrastructure to customize the local console to your needs, or potentially integrate it into any existing infrastructure you may already have on that specific site. So let's dive in a little bit more into the details. What you see on the screen is a quick overview of a environment that has an air-gapped deployment. So we see ZEDEDA Cloud. We see an air-gapped environment with some number of edge devices, and we see an instance of Edge Sync. So Edge Sync is a piece of software that we deploy as a Docker container on-prem, and that is the magic, the bridge between the disconnected and the connected environment. So let me talk you through what is a typical workflow, and hopefully we'll be clear on how Edge Sync as a solution fits into the daily life of operating this disconnected infrastructure. So first of all, on day zero, there's a few prerequisites for operating this infrastructure. First of all, on day zero, there needs to be a operational ZEDEDA cloud environment. So even though these devices will be operated in an air-gapped environment, we will still rely on ZEDEDA's cloud environment to be involved. And I'll talk more about what that means in just a second. The second thing that is a day zero prerequisite is to deploy one or multiple Edge Sync instances in your air-gapped environment. As I said, the Edge Sync itself is a Docker container-based solution. You can have a single instance manage multiple Edge nodes, or you could have a one-to-one relation between an Edge Sync instance and Edge nodes as your deployment requires, or what makes sense for the deployment model at hand. So once you have that in place, let's talk about day one, i.e. deploying Edge nodes in this operational environment. The idea is that at day one, you onboard Edge nodes on ZEDEDA's cloud solution as you would do today, pre-Edge Sync. So you onboard these devices in an environment where you do have network connectivity to the cloud. You do as today, as I said. The one thing that is different, you will now enable Edge Sync in the API, in the GUI, in Terraform, depending on whatever user interface you may be using to consume your ZEDEDA infrastructure. Enabling Edge Sync means that we tell the edge device that there is Edge Sync in play, and not just that, it also tells the device what specifically is the Edge Sync instance it should be talking to should it ever be disconnected from the cloud. So it means you provide an FQDN or an IP address that points to the Edge Sync instance. So then you continue with your onboarding. Maybe you already want to deploy your application stack on that node. And once that node is fully ready, we're now in a position to deploy the node in the air-gapped environment. So you would disconnect it from the environment where it had internet access, and we did our onboarding exercise. Now you transfer that device into the air-gapped environment and effectively run your workload in an air-gapped setting. So the interesting piece, of course, is how does operations work in this scenario? So there's a few things to talk about here. You see a local operator. That local operator can interact with the Edge Sync instance to operationally manage the nodes in this air-gapped environment or disconnected environment. So that means, for example, monitor the running applications, watch the CPU, memory, restart an app, purge an app, restart a node, shut down a node, those type of operational steps. The interesting piece is how do we deal with configuration changes in this disconnected setting? For example, maybe you want to bump up the application versions for this air-gapped environment. How would you go about that? So what we have done is we have decided to keep ZEDEDA's cloud the single source of truth for configuration state. So even though your node is disconnected from ZEDEDA Cloud, if you wanted to make configuration changes to this deployment, you would still go to the ZEDEDA Cloud interface, make whatever changes that you want to make to that set of disconnected devices. For example, bump up the application version. Of course, their node is disconnected, so it will never pick up those configuration changes directly from the cloud. And this is where this specific part of the picture comes in. So the local or the operator using the cloud platform that makes the configuration changes. One of the things we've added as part of Edge Sync is the ability to download the configuration of nodes. So the operator that is interacting with the cloud has the ability to download a JSON asset, a file, and can subsequently use any kind of out-of-band management method to get that configuration to the air-gapped environment. So maybe you put it on a USB and bring it into that environment. Maybe you have other means of somehow interconnecting networking-wise into that air-gapped environment. It doesn't really matter to the solution how you get that configuration to the air-gapped environment. What matters is that you have a means of getting it there. So once you have that configuration in the environment where Edge Sync is operating, the local operator takes that asset, that file or set of files, applies it to Edge Sync, and Edge Sync will push that configuration change to the nodes to effectuate the configuration changes that were made in the cloud. So using this method of keeping the cloud as a single source of truth ensures that there's always consistency between the configuration in the cloud and in the disconnected node. So this is also the means to ensure that you can always jump between disconnected and connected cases, because there is never a drift in terms of configuration state between the two. On top, this is also the thing that enables fleet level management of disconnected devices. Because let's assume that you didn't take this type of approach and you would have a local configuration interface on your device. Now, effectively, configuration management has become like a local activity disconnected between maybe 10, 1500, 500, 1000 locations where you may have disconnected assets. So by using the cloud infrastructure and the fleet management capabilities that it brings you, you can effectively maintain the benefits of fleet management versus dealing with management on a node-by-node basis. So having gone through the sort of high-level steps of how it operates, I wanted to talk very briefly a little bit on how it works. I'm not going to go into the details, but at least give you sort of a high level view of what is the principles behind Edge Sync. So Edge Sync has kind of two interfaces. One is a interface towards the Edge node or nodes that it's managing. That is a standard Eve protobuf interface. So that is the same type of interface that an Eve node uses towards the cloud management platform. And then the right-hand side of the picture is basically an HTTP API where you as a user, as a local operator, can interact with the device. So as I said, it's an API endpoint. This means that you can create your own HMI interface, your own GUI to consume the data. And it's fairly straightforward. You have a notion of a set of devices. Those devices have information, they have metrics. I can query those. I can post commands to devices, things at device level, things at application level, and I can post new configurations, the ones that you downloaded from zCloud, to that local instance, and effectively create a local console that way. So hopefully that gives you a little bit of an idea on like the mechanics behind Edge Sync. Then finally, just to wrap up, a few of the benefits of Edge Sync. So as we talked about, Edge Sync provides a mechanism to manage nodes in an air-gapped environment while maintaining fleet-level management capabilities. It provides an API that allows you to integrate the management of these edge nodes into your own infrastructure, your own operational stack, reporting tools that you may have already on site, or allow you to build a GUI as appropriate. It provides a future-proof solution. It allows you to seamlessly transition between connected and disconnected states. And finally, it does so by preventing split-brain scenarios. So we ensure that zCloud remains the single source of truth, ensuring that there's never discrepancies on what is the state of a device, what exactly is deployed on this device, what is the state of the application stack on top of this device. It is as the cloud indicates, because that is the only place where configuration state is generated. So hopefully this gives you a good overview. Edge Sync is available for you to use now. So should you have an interest in getting your hands dirty on Edge Sync, please feel free to reach out to your ZEDEDA pre-sales or sales contacts, or feel free to drop me a note, daniel@zededa.com, if you need any help on this topic. And with that, Raghu, I will hand back to you.
Oh, thank you. Thanks, Daniel. There are actually a couple of things a lot of people have asked me when it comes to Edge Sync. ZEDEDA prides itself for the security that we provide for all the assets out in the field, and also the communications between our cloud and the assets out in the field. So can you comment on like how Edge Sync also provides that security, and can I just take the configuration? Is it secure? If I put it on a USB, like would somebody be able to look at it? Can you comment about that aspect of it?
Yeah, great question, Raghu. Yes, so as I said, the file is effectively a JSON. However, it's an encrypted file. So whatever configuration state that you're transferring between cloud and that edge node, it is a fully encrypted blob of information. So nobody in between, the download from the cloud and the upload into the device has the ability to, one, see what is the content of that information, because there might be cloud init information in there. There might be other information in there that you do not want to share with intermediaries. So you cannot decode what is that information, and also you cannot modify the information. So it's not some text file, and today we're using V1, and tomorrow I edit it and I'm going to make it V2, or I'm going to point it to a different data store that is under my control. None of those things are possible. The full blob is fully encrypted between the cloud and the device.
Perfect. And another question that comes up in terms of Edge Sync is you're asking me to deploy an application in the local infrastructure. Now, do I have to manage that application? Now, do I have to have, what happens if that application goes away and like it just restarts? Will I lose something? So can you comment on the statefulness of the Edge Sync application, whether it is a container or whether people do things around?
Yeah, so good point. So as I said, Edge Sync is a container solution, right? So it's a relatively straightforward way for many operational environments to deploy. It is a stateless application. So Edge Sync itself does not maintain a database. It does not maintain any state. So if I take it out now and deploy it in an hour, it will seamlessly connect back. There's no state loss. There's no state maintained as part of the application. If that is something you want to do as part of your HMI interface, of course, that is a valid choice. If you want to be able to go back in time, what was the CPU load of this specific application 3 months ago, then clearly some database comes into the picture. But Edge Sync itself is a stateless application.
So what you're telling me is like, I give Edge Sync a fully encrypted piece of configuration, and the end device gets that configuration, and only that end device can decrypt it because of the encryption is between the device and the cloud. And Edge Sync itself is just an intermediary. And like if it goes away, and if you want to install another Edge Sync, then as long as I provide that configuration again, everything will be normal. So like you don't really have to actually manage the configuration.
100%.
Okay,
Yeah.
perfect. Okay.
100%.
Sorry, I don't want to take on the questions all by myself. Like, Jeff, the one question for you is when you are talking, I think like we lost you. Okay, perfect. So Jeff, one question for you is for SLB and the kind of connectivity solutions that you are dealing with. Do you usually like deal with multiple types of connectivity all at once? So like you talked about having a LTE, 3G and VSAT connections. So do you have all of them all the time available, or is it like a different combinations? How does that work for you?
It depends. So it could be at some locations they'll roll up and maybe only the LTE is working. Others, maybe the LTE is not working, and so they have to flip to VSAT or something like that.
Okay.
I do know that we do have deployments where we're totally isolated and air gapped. So that does exist as well. Those are usually the data is being delivered internally to that air gap system, and it just kind of stays there. So that does occur. That's more in the plant operations and stuff like that we'll see that type of event.
Okay. I think we are 5 minutes over the time. So if there are no other questions, I'm going to stop this webinar now. Thanks a lot, Jeff, for your time and the insights into like how services, oil and gas and energy services companies operate, and what is it? I mean, the story about like 200K per hour on an offshore drilling. I'm sure like a lot of us know it is expensive, but we didn't know like it was that expensive. Okay.
Yeah.
Yeah. And Daniel, thanks a lot for the great presentation about Edge Sync. And everyone else, whether you are watching it right now or whether you are watching it later on a webcast somewhere, if you are interested in Edge Sync, please reach out to Daniel or anyone else at ZEDEDA. If you already have a representative you're working, whether it's a pre-sales or a sales representative, reach out to them. We would be more than happy to like do a demo or get your hands on Edge Sync product so that you can get your hands dirty. Okay. Thanks a lot, everyone. Jeff, again,
Thank you.
really appreciate your time. Thanks, everyone.